I'm listening. Speak now. Are we doing okay? Are any questions about the procedure? Now, what y'all doing, y'all doing exactly what I had to do when we got this software. Exactly. Y'all doing exactly the same thing. This is the way I learned how to do it, by doing what? Reading this manual. Yeah. Setting up this first work cell, and then writing my first program. And then after that, we move on, right? So y'all don't have any problems, any questions? Okay. As soon as we start, as soon as some of y'all get the work piece made and up there, we'll lecture on basically how to do the program, how to set up y'all's first program on there. What we're going to do, I don't know if I've got it in here or not. We'll see. Is we're going to write a program, and we're going to refine the program too. The program that they've got has got a few little problems with it that if we were on a real robot, we wouldn't do some of the things they do. One thing is the size of the box. That's one thing that I realized right off the bat. The box they had, and then they wanted us to weld down the back of the workpiece. You couldn't even reach it. So that's why we reset the size of the box. Oh yeah, y'all can go ahead and start. I mean, even if you, so we're in lab predominantly in this class. So even if you come in a little early, if I've got this thing out, y'all can go ahead and. So this is. Let me hook up the projector and let y'all show y'all what we're shooting for. Hold on, Kathy. Trying to turn the projector on with my calculator. So a robot, and of course what you're doing right now is building but it's actually the work stand, and then so this would be like a welding table, and then this is the piece right here you're going to build to weld. You can set the color to any model you want to. I've changed the color of the floor, or whoever did this. I think I actually ripped this off from one of the students. And what we're going to do is we're going to simulate. This is the welding torch. First time y'all are going to build a welding torch, you're going to build a model of welding torch, and they're going to give you all the dimensions and everything. But by the time you get here, you're going to import this welding torch. So this model is already there for you, and it'll step you through how to go in and actually import a model. And then what we're going to do is we're going to do what? So this is the program we'll finally end up. This is going to be your first program. Let me slow it down. And we'll show you how to do this too. So this is where we can set the playback speed of our program. I need to reset it. So what it's going to do is come down and it's going to weld one side and flip around and weld the other. This will be the first program that y'all actually end up writing, for your robot. But you're going to do it basically exactly the same way, but it's going to be a little easier because here we've got a computer that can aid us in positioning the robot. So here, if we want to get to 5 millimeters, by George, we can get to 5 millimeters, but it's going to be just as accurate as your workpiece is at. I've been tempted to try to make this. Of course, we'd have to make it smaller for our little robot because it couldn't even get over the box and get over the other side, get the torch on the other side and do that back weld. That was the problem that we had. So this is what y'all shooting for right here. is to do what? So you're gonna you'll build these, and then we'll move. So by the end of lab 1, you should have the work cell built, and then lab 2 will come in and actually start our programming and set up what we call collision detection. Let's see if I've got it set up on this robot. Collision detection is really a neat feature of simulation, because I don't see. Let me find my collision detection. Because no, I don't have it set up yet. So I'll set that up and show y'all that when we get there. But collision detection allows us to detect collisions in a software environment, right? You'll understand that. And you can collide the robot in software, but the guy from Mercedes said that one of their big welding things over there costs over $50,000. And all your welding, since there's so much current, all that welding out there is copper, and copper is not a real strong metal, right? And we're trying to get in to within nanometers of devices, and if you collide that thing and you bend it just a little bit, then all the welds are going to be what? Off. And then they got to do one or two things. They got to take it off and put another one on there, and then they probably got a jig or something that they can put it in to realign it, because I doubt if they scrap a $50,000 welding rig just because it collided. But they'll probably take a little while to get it back in perfect alignment, right? A welding jig would be something they set it down in, and then they can move clamps and stuff in to put it back into alignment. We had a company over here, Siltech over off of I can't remember the road now. They built a jig that would come in and realign the joints for the solid rocket boosters on the shuttle, and it was a real neat thing. Every time they send it up, the actual joint, they would send it up. They wouldn't send it up to these people. These people actually build it, but they would put them down in that jig and do what? And it would just come in on each side and just realign that ring perfectly. That's one of the things they did after the Columbia blew up, because they figured out that's what was wrong, that one of the seals was in there, rubber seals in a solid rocket booster. Couldn't you imagine putting rubber seals on your pistons in your engine? So they had rubber seals around there. They had about 7 or 8 of them, but that's what happened. Those rubber seals ruptured in the hot exhaust got out of there. Okay, guys, so y'all see what y'all working on? So I'll just kind of leave this up here, so as y'all move along, you can kind of compare what you've got to what's up here. But this guy's going to step you through it. But remember, you need to learn this, because if you take the test, when you take the test, you're going to be able to use this manual, but it's like taking the National Electrical Code test. It's an open book test, but it's also timed. So if you go into NEC test and you have to look up everything, you're not going to finish the test on time. So having a reference book's okay, right? You understand. But you need to get an idea of how to import a model, because if you got to go in and find it now and look everything up, you're not going to have enough time to finish the test, right? That makes sense? So kind of fill out what you're doing, and instead of blindly following these things, figure out, say, okay, this is the way you add a model. Now, you can make notes, all the notes you want to, while you're doing these labs. So, like, how do you add a model? That should be, some of that should be on that quick reference too, but that still takes a little while. So, you okay? Because what we want to do in the CAD tree, so when you look at my CAD tree, okay, here's my box. You don't see the workpiece. Why don't you see a workpiece? You got to add it to here. Okay, understand? Don't add it to the world, add it to here. Okay, does that make sense? And it still comes up in the center of the robot? Yeah, that's what we're calling it, DAI, and we added it right here. Okay. And then this would be the box. Let's see. And we have no positional information here. and then we add it to the box. We have no positional information here. Oh yeah, we do. We have a Z. By the way, let me show you all a little trick. Are y'all ready for this? What we can do when we're in the CAD tree, and this gets pretty important as we move along, especially when we're trying to move down the robot model. So when we start attaching something to the robot, where we're going to attach it to? We're going to attach it to the flange, right? Y'all understand that? Well, see how long it took me to get to the flange? Okay. Well, what we can do is we can come in. I'm going to close this up. I'm going to just open my CAD tree. Right here, you got this little old pointer finger right there. See that? I'm going to click on this, and then I'm going to come down here, and wherever I want to position in the CAD tree, what I can do is just click on that model. And it goes to wherever that's at in the CAD tree. So instead of me trying to even find, even trying to find where that box is at, I could come up here and just do what? I could come over and click on that right there, and it'll automatically take it to me, that model in the CAD tree. Y'all see what I'm doing? Yes or no? Yeah. So this really, the more you add, the more complex trying to find it inside that CAD tree becomes. Yeah. And here you don't have to find it in the CAD tree. All you got to do is what? Yeah, I click on it and it'll take you. So if I wanted to go to of course it don't work on the floor model, but every other model you have, no matter where you want to go to, you just click on it and it'll take you to that model. So what we're going to have to do is figure out, this is where the workspace is supposed to be. Here. This is where the correction was made. So sometimes you're going to have to figure out where to put it. So which one did I tell y'all to change? So this one is 200. On which one though? This one or the vertical one or horizontal one? Or the horizontal one? Okay. So 165, that's where the Z is supposed to be. This wasn't high enough? Yeah, so yours came in, for some reason, yours came in the middle of the robot right here. So what we would have to do is we would have to go up 300 plus 165. Yeah, because this is supposed to be I'm sorry, this guy right here. So it's in the center here, right? And what's the height on this one? So the height of 30. So if it's in the center of the box, we would have to come up and give 300 plus 1/2 of that. On the instructions? Yeah, but this is not supposed to be 600. This is supposed to be 300. The one they did in there was 600, right? And what they thought it was going to do was going to come into the middle of the box. But yours didn't come in the middle of the box. So if it came in the middle of the box, it would be 315, right? Ours came into the middle of the floor, but ours is on. So 315 is right, but it's right because we changed the height of the box. Does that make sense? Probably not. So what? Yeah, y'all listen up. The problem, y'all listen up. The problem is that y'all listen up. Okay, what we're trying to do is we're trying to position this right here. Now, in the original lab, they set the height of it to what? Okay, they set 600 millimeters. All right. Now, when they attach it, they expected it to come into the middle of this box right here. Right, you understand? So that would be half of 600 would be what? 300 plus half the height of this, which is 30 millimeters. So that would be 315. Now, for some reason, would be maybe to the center of the robot. Okay. And what we're trying to do is we're trying to put it right here. Okay. So how far are we going to have to move it out? We moved it out 1,000. Okay. So what are we going? How far are we going to move this one? 1,000. Okay. That will put it in the center of the box. And we're sitting now, but still you're down here. So what we're doing is we're going to have the height of our box, which is what? 300 plus half the height of that, which is going to come up the same as the instructions tell you, but for a different reason, right? You'll understand what I'm saying. So the simulation thought it was going to be put out here, but y'all was put out here, and that's the kind of stuff we got to figure out. Because sometimes the box does not come up where the simulation thinks it's going to come up at. Yeah, you got 1,000. You need to add 1,000 to the X. If it comes up here, if you make it and you don't see it, then where do you think it's at? It's in the box, which is where it's supposed to be at. Okay. But if you see it over here, then you're going to have to do what? Do the math. So since we moved the box out 1,000, it came in over here, we'll move this out what? 1,000. And then we're still down here in the center of the floor. So we'll move it up 615. What it is the full height of the box plus half the height of this. See it come up still on the top. Did it come up touching the top? Did it come up right? Have a rotate the box. Because y'all know how to do the rotations, right? Okay, y'all look up. Everybody okay? Everybody looking. These are all your positions right here, and this happens every once in a while where people will come up here and they'll screw around and get their model off their screen. Okay, y'all see that? Well, you can come over here and use these scroll buttons all day long and they don't do anything. So this is what we do to move the robot around. This guy right here is very, very important. So no matter where it's at, it's going to center it. Okay, see that? Okay. This guy right here allows us, see this guy, see which one I'm using? Okay, this guy is our zoom. So I can come up here and just highlight what I want to look at. So if I wanted to see the actual, if that thing is touching that block, I could zoom in on it, right? I'll see that, the box. Then we've got these guys right here. I'm going to come up here and touch this one. Can y'all see that? And this allows us to move it up and down. And then what we can do is we can literally come up here and I need to recenter it. We can come up here and look to see if it's touching the top of the box. And this is what I usually do to check my math out. Back in the center. This right here allows you to spin it around any way you want to. Can y'all see that? So not only can we move it around, see what I'm doing? Are you okay? Dang it, Rich. And then what we can do when we get up real close, what we can do, we can come up here and move it until we can see that you can see it's touching the box, right? And if so, that's why you would check to make sure we did our math right. We'll show y'all later on how we can make measurements. We can measure this to see if it's the right size and everything. You know, are we okay? Now, okay, go ahead. I'll talk about this. I'll talk about this later on. Can y'all see this, the Cartesian thing right here? We'll talk about how we get that up there in a minute when y'all get to the programming aspect. And talk about what that's there for. Are we okay? So if you ever lose your robot, do what? By the way, we have some predefined views. That's this guy right here. So see these right here. So this allows me to view from the top. This allows me to view from the front. This allows me to view from the side. This allows me to view the slant. This right here, that's the one that's built in. This gives you all these other guys. So you can basically look at it from the bottom. You can look at it from the look at it from the top. See what we're doing? Okay. So this is the way you can actually visualize. Should have used one. Okay. So that's what these are. So these are predefined views to get it in a certain position instead of you trying to maneuver it with these guys up here, right? You understand that? And come up here and grab this and flip it around. Well, if you want to look at it from that side, what can you do? You just come over here and say, okay, I want to look at it from the left side. That. You understand that? Everybody okay? It'll be in your toolbar somewhere. Well, it could be. You can maneuver the toolbar to put things in the position you want them to be. So if I don't want this, I can grab it and I can stick it in there. So just because it's there on yours don't mean it's there on his, right? Understand? So we can manipulate the toolbar. I don't want that right there, so I'm gonna put it back. I don't know what. Oh, I don't see an error. Yeah, I don't see what you're talking about. That's where I stuck it a while ago, and then when I moved it out, it left it there. So that's where I brought this one up, and I stuck it right there. If you don't want that in there, then you could grab this over and fill in those spots. But see what happened is when I pulled this one up there, it stuck it there, and then when I pulled it out, it didn't automatically move this over because that's the position it thinks I put it in. So if you want to fill in all those blank spots, just drag them over. Okay. There you go. See there? So you say what? Finally, right? Finally. Okay, it's okay. I don't know what you mean. Well, you don't add a box. So what you're gonna do? You're not gonna add it in the CAD tree. It says the add button in the CAD tree. So when I come over here and I look at my CAD tree, there's an add button right there. We're not going to use that add button. Okay. We're not going to use this add button. So what I'm going to do is I'm going to open up my box and I'm going to add a box in there. So what you're doing is you're not adding the box to the CAD tree, you're adding the box to a workpiece. So what you're not attaching the model to the world, you're attaching it to that other, to the work, right? Yeah, you got to remember you got two places that you can add. You can add to the world, okay, or you can add to another model. So if I want it to pop into the center of the other model, then I add it to the model. If you add it to the world, it's going to pop up in the center of the robot. That's why it kind of confused me a while ago. So what should happen when you add this other box, it should pop up in the center of that guy right there. Huh? Yeah. You need to sign it out and sign it back in at the end of the. So it's got a number on it. So sign it out right there. Yes, sign it back in. That's not yours. You don't take it home. Yeah, that's no. Yeah, that's the HK. That's hardware key. Later on, we're going to be signing out one of these. These are compact flash cards, and that's where you check the CF.